Good evening. Welcome to the QCIS channel. We're on this channel, you get a daily dose, science, technology, engineering, and math. My name is Leon Jones, and tonight I'm going to talk about an interesting subject. It's from the discipline of civil engineering, and it's called accelerated bridge construction, or some people call it rapid bridge construction. And with accelerated bridge construction, you can actually keep traffic open for a long time. Now, when you do traditional bridge construction, sometimes you may have to close the bridge down for a while if you do the whole bridge, uh, or you'll have to do half at a time. But when we deal with accelerated bridge construction, it's very cost effective. And I'm going to show you why. Let's go to the screen here. Well, it's no secret that America's bridges do need work. According to a 2016 report from the ASCE, which is the American Society of Civil Engineers, almost 40% of the nation's bridges have been around for 50 years or longer, and 9.1% of bridges are structurally deficient. Now, to address the backlog of work that needs to be done and reduce the time it takes to plan and build bridges, many organizations, such as the Accelerated Bridge Construction University Transportation Center at Florida International University, FIU, have promoted a new construction method called accelerated bridge construction. Now, I will tell you, I believe it was at Florida International University where they had a team of designers and they designed a bridge and it was accelerated and it did collapse and it killed some people. So there are some disadvantages to accelerated bridge construction. Now, when we talk about accelerated bridge construction, we have to get into the methods. So this new method, and I know they use it on the Pennsylvania Turnpike as well, especially when they were going across the Susquehanna River just outside Harrisburg in the early 2000s. So the reason why this new method has come into play because it reduces traffic disruptions and risk for both drivers and construction workers, since it shortens time it takes to install a bridge over a roadway. However, and it's getting into the point that I mentioned about the bridge construction at FIU, Florida International University, in the light of the recent collapse of a pedestrian bridge being installed at FIU in March using this method. This is March around 2016, 2017, and 2018. Some people have expressed their concerns about ABC, which is accelerated bridge construction. Now, the investigation into the collapse is still ongoing, so we don't know whether design, engineering, construction materials, or combination of factors were responsible for the tragedy. But this incident suggests contractors and municipalities ought to take some time to learn about ABC, especially if they're considering a similar project. Now, here's what you need to know. So, after I discussed everything earlier in this article, now let's get down into the nuts and bolts, the definition. So, what is accelerated bridge construction? Well, it's a process that involves constructing large portions of bridge or bridges offsite. Again, most of the time when bridges are built on site. What happens if it's a big body of water, you're going to have to divert that water by utilizing a cofferdam. Then you're going to have to pour a mud mat. Once you pour that mud mat, get your rebar together. Then you're going to have to pour abutments. Now, the abutments are basically poured probably through driving piles and using some, and I'm going to get into MSE wall later on. They're going to use some type of MSE wall to help stabilize the soil or the bridge abutments. And you're going to have to pour for your pier caps. Your cap is that beam that goes across. We call that the cap. And then your piers are basically, they could be column-like or they can be cylinder-like. That's the traditional way of building a bridge. You start with building the structure on site, and then you bring in the beams, they lay the diaphragms and everything in there, the cross bracing, the deck pans. That's doing the bridge on site. With this method, ABC, or accelerated bridge construction, large portions of the bridges are built off-site, and what happens, you can install them very quickly. In fact, it take a month or so to build a bridge, but this method, it takes within 48 to 72 hours. Now, doing so can reduce road closures, traffic delays, and overall project costs according to the Federal Highway Administration. Now, these bridges are also designed to have a long life. Now, in the case of the pedestrian bridge at FIU, the bridge was supposed to last 100 years. Now, the FHWA explains 3 ABC technologies used to construct these bridges. Number 1, we have a prefabricated bridge element and systems. Again, we start off with utilizing materials such as prefabricated bridge elements and systems. And what it is you're going to have the bridge components built off-site or adjacent to a site and then installed in place. They often include the deck, beams, and railings. And I'm going to show you a video or 3 short videos on how they do everything. Now, I've seen this one on the Pennsylvania Turnpike. Then you have the slide-in bridge construction and the process of installing these prefabricated elements or replacing an existing bridge with a new one. That's what the Pennsylvania Turnpike did. Then you have your geosynthetic reinforced soil integrated bridge system. That's a method for constructing abutments and approach embankments that are less likely to create a bump at the end of a bridge, which can cause a common issue for some bridges. Now, one of the main elements of the bridge are installed. Crews can basically complete the project by adding pavement and other needed components. Again, let's go over that again. One of the main elements of the bridge that are installed. And when these elements are installed, crews can complete the project by adding pavement and other needed components. Now, while ABC does speed up the processes of building and replacing bridges, especially the actual installation, it's worth noting that it doesn't mean that the whole process is quick. The design and engineering phases of ABC can take several lengths of time since everything has to be perfect for the installation to go smoothly. Now, the benefits and risks of prefabricated bridges. Now, many bridges have been installed in the United States using ABC, resulting in many benefits. We're going to get faster installation time, fewer traffic disruptions and road closures, worker safety will be increased, construction costs will be lowered, and there will be less or a reduced impact on the environment. And then the lifespan of the bridge and the quality of the bridge, they're also going to be improved. Now, with any construction method, there are risks associated with. There are risks. Again, with any construction method comes risk, and ABC imposes some risk compared to conventional bridge construction. And here's why. When we utilize the method of ABC, you must have specialized equipment like self-propelled modular transponders to move the prefabricated elements in place. This equipment must be properly used and managed at the job site. All load cases for the bridge must be considered for the installation. Because the installation process occurs so quickly, the execution of the project requires the right personnel and clear communication to reduce risk. Now, whenever, you must understand this is very important. Whenever any type of new construction method is used, having people with the right knowledge and experience is very crucial. So any contractor thinking of using new methods like ABC, you need to do your homework. Now also, keep an eye out for the investigation results. You see, some engineers have pointed out that the bridge at FIU used an unusual design, but it's too early to say whether that played a role in the collapse. So I'm not even going to jump in the conclusions and blame ABC for what happened. But one must understand any contractors or organizations like design firms thinking about ABC for future work should be on the lookout for the results of this FIU collapse of the pedestrian bridge down in Florida. Why? Because they may provide some insight into what risk factors require extra attention during this type of project. Again, you're going to get into this type of construction. Be on the lookout for the results of the FIU pedestrian bridge collapse, because this is going to be a recipe for research, because you're going to need insight to find out what risk factors require any extra attention when you perform the work on this type of project. And it is also it's also worth noting that materials that are prefabricated in general are playing an increasingly role in construction. Yes, this is worth noting because in construction we deal with a lot of materials, but there are a lot of prefabricated materials that are propping up. Again, there are a lot of prefabricated materials that are propping up. Now, in general, when it comes to construction, again, in general, these prefab materials are playing an increasingly large role in construction, even if those materials aren't the size of an entire bridge deck. New materials and structures change on site processes, and these changes are something that all contractors need to pay attention to. So remember, all construction projects involve risk of some kind, regardless of whether they're using traditional methods or new methods. So again, when we deal with building bridges. Now, this type of method has been around for, we'll say, 20 plus years. Now, I did see it in Pennsylvania when they built the Susquehanna Bridge, which is part of the Pennsylvania Turnpike, because what they're doing to the Pennsylvania Turnpike is they're widening the turnpike from 4 lanes to 6 lanes. That means 3 lanes in each direction. And this method was used. And you're going to see a video, about a minute video from the Pennsylvania Turnpike on how this ABC construction works. Now, fair use. These videos are for educational purposes only. And after I finish with my video, I will put the link under the video description section. Be on the lookout for that. That way you know where I got all the information from. But let's go ahead and share some screen, and let's look at some videos. Viewpoint is the name of this company, and what Viewpoint is, it's a software that can help you track compliance issues, improve communication between teams, which make collaboration a lot faster. I'll be bringing that back up in a minute. Fair use. Let's try to get a little bit of videos in here. And here is the first video. Let's do the short one first. This is from PennDOT. I used to work for PennDOT. It's a 41-second video. I even have some more videos here. Let's do this one with the railroad bridge first. See how it's done with the railroad bridge. Fair use. Fair use. And by the way, this is a rendering of what the process looks like. Fair use. Let's continue. And let me go back again to address the introduction. Let me make my correction here. That was the rendering of how the process actually works. Now you're going to get an idea of how they put everything together. In fact, this is almost like taking a box culvert. It's post tension, and what it is you pull the cables together, you seal it while it's in place. Let's take a look at this concept called accelerated bridge construction. Fair use. See how they're sliding everything in place. Now, this bridge must be over there in Europe because it is snowing heavily over there, very cold. And generally, here in the United States, they do not install bridges during the winter time. And this is a light rail bridge, and they're installing it in spans. Let's continue. All right, let's get some more. Let's go to this one. This is from the Pennsylvania Turnpike. Their use. I'm sorry for the silence. This video is very silent. You're just seeing a rendering. Let's find another one here. This is from the Michigan Department of Transportation. Their use.
The $1.5 million M25 bridge reconstruction project over the White River in rural Huron County was completed this summer using the latest technology in bridge building. Accelerated bridge construction uses elements that are fabricated off-site and assembled at the bridge.
The abutments were precast. They were made in the factory, so they were brought out to on-site. We set them into the footing, which was cast on site.
In addition to more consistent quality, the use of precast materials saves time and money and reduces motorist delays. The detour for this project was removed 3 weeks earlier than it would have been with traditional construction. The structure sits less than 9 miles south of Harbor Beach. The original bridge was built in 1952 and removed in late April, making way for the new 48-foot span, which is slightly longer than its predecessor. 8 concrete box beams were put into place to create the 2-lane bridge. Steel cables run through the beams to hold them together.
Once we get the beams set into place, we'll pour the diaphragms, we'll pour the back walls that go between the beams over the abutments, and then we'll put the post-tensioning cables through the conduit you see in the beams, and then we'll tighten them together, and that'll hold the beams from separating.
The Michigan Department of Transportation is dedicated to providing the highest quality integrated transportation services for economic benefit and improved quality of life.
I want to talk about a bridge I designed almost 20 years ago. It was the first ABC, or Accelerated Bridge Construction, bridge in our state. The goal of the project was to build a bridge as fast as possible using accelerated bridge construction There wasn't a lot of information at the time for ABC bridges, so this was a demonstration project. It was felt that manufactured precast parts assembled on site would provide the fastest construction timeline. So I came up with this idea of individual precast panels tied together with post-tensioning and pre-tensioning. So I started with this little cardboard cutout I'd made on the left. This is before 3D really became available in the office. So this is my panel here on the right. This is one half of the bridge, and we're going to tie it together with different techniques. What's going on here is there's pre-stressed strands that are going down like this. There's 4 of them. Panels were pre-stressed in a factory. Then we're going to lay them out. They're going to sit on the beams right here. This is the center line of the beams. And then we're going to post-tension it right along these channels. So here is one of my panels, and you can see.
Again, when you hear the term post-tensioning, that method is used to hold everything in place. Again, box culverts use post-tensioning. Now, all of these components are prefabricated. That means they're made in the factory and then shipped on to sites. And the ABC method, they also have the other method where they actually slide the bridge in place. Then you have the box beams, and mainly what you're seeing here are box beam bridges. But you're seeing how long it takes to construct this bridge, and you'll see how cost effective it is. Now, again, there are a number of states that are using this method, but it does have its flaws. Again, the FIU bridge, which is a pedestrian bridge, that should give you an insight regarding the risks. Fair use. Let's continue.
See, this is where we pre-stressed it. There's 4 of these. And if you look, you can see these coils. We had to put these at the end because to get development length for these pre-stressing strands, we were worried about it bursting out. So we had to put these coils around it to contain all the stress that's in there from the pre-stress. Again, these are going to be the channel where the beams are. And if you look down here, these are the connections for our posts that help with the barrier rail. It was a bit of a challenge to design this so that we had the pre-stress in here. And then these bars right here, they would hold this thing apart. So they'd have force like this and like this. And then the pre-stress would have all this kind of force on these sections. And I was worried, if you saw the video at the beginning, that these things would buckle when they were being lifted, but it all seemed to work out. Here's a cross section, 4 beam cross section, 30-degree skew. You can see the span, 151 feet, 4 total short spans. Barrier rails on the outside, and you can see how the panels, so this is one section, one panel on one side and another panel on another side. And you can see in here, this is where all the post-tensioning is going to go right in here. Here's an end panel. And what we needed this for is once we fed the strands through the channel the whole length, they had to be splayed out so that you can actually get the machine to work. And then what we're going to do is we did a closure pour to tie all these strands so they wouldn't move. So I mentioned this was before 3D computers. I had to build a little model to explain it to people. So there's the beams. This is the end panel that you would put on. Then you put the interior panels. And you can see here, this is where the post-tensioning is going to go through the channels, right through here. Before we could do that, we had to pour closed all the transverse channels, not the center channel, so that when we put pressure on it with the post-tensioning, it would squeeze everything together. There's the post-tensioning coming through the channels, then we'd grout or fill that with concrete, and then we'd finish with a closure pour. Unfortunately, the bridge we had to replace was a marsh arch. These are pretty famous. It's a beautiful design, lasted for many years, but the problem with all the big machinery that farmers have, they couldn't fit through it and they kept damaging the marsh arch bridge. So removed the bridge, started putting some piles in for the abutments, put a couple of studs on it because the abutment's going to be precast, it's going to come on, and then we're going to grout it or concrete it in to these studs. We had pipe piles for the piers. There's for the piers. Had to design something, a pier cap that would come and just sit on it. You can see this is when they were pouring it. This is lifting it into place, putting it over top, filling it with concrete, making the connection between the precast and the pipe piles that were there. You can see how it looks. This is an abutment. It's precast. Same technique. We came and we put it over top the piles and concreted in these different holes here to make the connection. You can see they're dropping it down.
Now this is amazing because generally abutments, yes, you will use pipe piles or you'll use I-beam piles. And then you will use, again, some type of MSC structure to retain the soil. Because when you have pressure with soil, here's what it looks like. Okay. You have your abutment and you have soil. Now, your pressure is going to be triangular. So that means your centroid is going to go up about maybe 1/3. So it looks like this. It's a triangle. So in statics, you're going to go ahead and use that formula. You're going to find all the moments and you're going to find the forces. And in fluid mechanics, you'll have the same type of problem. But basically, you have the retaining wall structure through the MSC panels to basically hold back that soil, because that soil produces a lot of pressure and it can cause a cave-in. Now, that's building the abutment the traditional way. Again, with the piles. And generally also, abutments can be built across water by diverting it. Well, let's say your piers, your abutments are at the end, and your piers are in the middle. Again, what you're looking at right now is a one-span bridge here. So this is amazing that they can actually construct an abutment like this precast. I've never seen it. So what I'm doing is getting my knowledge. I know how abutments are built. So let's continue. Again, this is not the traditional way of building abutments. Again, I know how they're built traditionally with the piles. Again, they use piles here as well. But you see, they don't use the MSC structure to hold back the soil. And you look at the creek, looks more like a marshy type of creek as well. But let's continue.
They're going to fill it with concrete. It all came out, but that's part of it. The beams are in place, some diaphragms across, starting putting the panels on. I was really frightened by this when I saw this picture. I wasn't on the site. I was worried that these strands, there's a lot of compression coming in here from the pre-stressed strands for them. And if they lifted it wrong, I was worried that it would break and it would hurt somebody. But fortunately, that never happened. Starting putting the panels down, see how they go. And I designed them so they sit right over the beam. That's where the channel and the post-tensioning cables are going to go. These are little adjustments so we could sit on top of the beam and make everything nice and level. Pouring the transverse joints, putting the post-tension cables down the channels so we can tie it all together. Come through the end panel. You can see they can use the machine to pull it really tight. Then we're going to concrete those joints up. Once everything is done, we pour the end section and tie all the post-tensioning cable into this so that it's one unified mass. And there's the final bridge. The cool thing about the design in my mind, because I designed it, was this whole bridge was in compression no matter what the load was put on it. That's pretty rare because when you're on a bridge, typically you get tension in the beams and different things, but this is so much post-tensioning in it, so much pre-tensioning in it that it's all in compression. Theoretically, it should never fail because you'll never get a tension crack. We made the panels a little thicker so that you could come by and grind off not exactly level, and it gave it a bit of a roughness to the deck. You can see the rest of the bridge. You can see how we did the transverse. We poured those joints. The post tensioning gives all this pressure, goes along. It's actually going to be compression in the whole thing, but that's what we did. Poured the diaphragms at the piers, abutments, and there's the bridge. So like I said, this is the first one that was ever done in our state. It was unique, and as far as I know, no one has ever built something like this again.
All right, let me see what I can find, see what goodies. Let's go to this 41 second. This is from PennDOT, my old employer. And that's what accelerated bridge construction looks like. It is a good technique. Now, I will say this, even though they actually build this structure at the factory, you're still utilizing concrete. Concrete must be tested. There must be samples taken. You need to know the load because it is a bridge. It is a structure. So you still need to do your slump. You still need to do your air. You still need to do your temperatures. And also, when you go out and inspect this type of bridge, you expect it the same way that you would a conventional bridge. I mean, for this type of construction, since there was a collapse back in I believe it was between 2016 and 2018, a pedestrian bridge in which there were fatalities. Well, you need to know what the brakes are. Are they using cylinders? That's the first thing you need to know. Or are they using beams? Beams give you that flexural type of test. And then how are they building the bridge? Are they building it where you just slide everything in place? Or are they utilizing box beams? Or are they utilizing I-beams? I mean, again, I gave you the 3 methods with this construction, and I believe it's relatively it's fascinating on how they can build a bridge that quick, but you must attach safety because there are going to be vehicles traveling across some of these bridges. So what I've just gave you was a good overview on accelerated bridge construction. And you want to know more about it, you can watch many videos on this type of construction. You can also come back and watch this vehicle. I give you a lot of insight as well. But basically, this is a type of construction that is very cost effective. You don't have to have too many delays in traffic. Now, again, I will caution you, however, the process might not take too long or the means and methods, but it's the design. Designs do change. And then depending on what you're doing, you have to get permits, especially crossing the water. You may need an NPDS permit, which you're dealing with discharge. You may need a 404 permit. You may even need a 105 permit, depending on which state you're in, Army Corps permit. And the permits and the designs, they actually take the longest because you may have to reestablish your design if one design doesn't work. But if you're inspecting this bridge, make sure you have the specifications and the standard drawings. Generally, DOTs, state DOTs, they do update their specifications every 2 to 4 years. So that concludes this topic on accelerated bridge control. If you like what I just presented, please comment, share, and subscribe. If you're looking for some political content, yes, looking for some political content, some scam content, check out my main channel, the 411 Talk Zone radio show channel, also on YouTube. And after I record all my videos from both channels, I will post them onto my Twitter page. Now for the QCIS channel, since it is an educational channel, I will post that up there onto my LinkedIn page. So that concludes everything that I have shown you. And I want to thank you all for watching this segment on accelerated bridge control right here on the QCIS channel. On this channel, get a daily dose, science, technology, engineering, and math. Until next time, my name is Leon Jones. I want you all to have a wonderful, gracious evening.